1.2 part 2. The materials, the topic's still the same. The only difference is instead of having absolute value graphs and absolute value equations, we now have quadratic. As you look through your notes, you're not going to see a single set of absolute value today. You're going to see a whole bunch of little tubes, right? A whole bunch of squares. Okay. What do you notice about this chart? Identical, yes? Did not change a single bit. Okay, so this is nothing new. It's still, if it's an added at the end, outside the parentheses, it's going to be up or down, direction of the sign. If it's added or subtracted in the parentheses, that's going to be your left or right, opposite the sign. Negatives are still reflections if you see a negative multiplied out front. Numbers multiplied out front are still vertical stretches and compressions. And if it's the division in there, it's possibly a horizontal stretch or compression. But again, they introduce the topic, but you don't really see it in homework. So you're going to see more of the vertical. Okay. We need a basic here, right? With y equals absolute value of x, we had to have that basic v that we could then move left or right, up or down, and we could stretch or compress or reflect. We need our basic quadratic graph. Do you remember? What's the shape of the quadratic graph?
V.
Not a V. Very similar.
The U.
It's the U, right? The official name is the parabola. So, what are some good x values, you think?
2, 1, 0, 1, 2.
Okay. Those same x values are the ones I like to use. So if we put them in, you're putting them into here, which is quant x squared. So like that first one's going to be negative 2 squared. What is negative 2 squared?
4.
Yeah, or in other words, negative 2 times negative 2 is 4. Beware if you are a calculator person that likes to put everything under the sun in your calculator. I would like to think we didn't need the calculator for this, but some of you, when working on your own, you like to verify, right? If you put this in the calculator just as negative 2 squared, your calculator might pop back a negative. Okay? In order to get it to work correctly, you would need to use parentheses. Okay? Similar to what I wrote here. Because otherwise your calculator is saying, okay, it's the negative of 2 times 2. So use those parentheses if you want your calculator to pop back positive. Okay? The other piece I'm going to say there, use your brain. What do we know about a negative squared? It's going to be positive, right? A negative times a negative is a positive. Okay, negative 1 squared. What is negative 1 squared?
Negative 2. No, positive 2. No, 1. Oh, gosh.
How about 1 times 1 is?
1.
1. Negative times negative is a positive. 0 squared?
0.
0. 1 squared?
1.
2 squared? 4. Okay. I will say that I tend to, when I do an XY chart, I tend to do this piece of the XY chart right there and then just reflect it. Because if I know one half of the parabola, I know the other half of the parabola. So, let's see. Negative 2, 4 is going to be left 2 up 4. Negative 1, 1. Left 1 up 1. 0, 0. 1, 1. Right 1 up 1. 2, 4. Right 2 up 4. Okay, now, it kind of looks similar to our V shape, doesn't it?
Yeah.
But it's not a V, right? Kind of when you work to connect it, I know, easier said than done at times, but try and make it not look like a V. Okay, try and make that bottom curve a little bit so it doesn't look like a V. What's our vertex? 0, 0. What's our axis of symmetry? Okay, so I will still agree. I heard both answers. I will still agree it is the y-axis, right? But if you have to put this in Savas, we've already talked. They don't want the y-axis. They're going to want the equation of the line, which is x equals 0. Okay. Pretty painless, right?
We take both on
Another 20 times.
I'm still going to want the equation, though, too, even when I'm grading something. Okay. Okay, let's do some practice. Graph each function, identify transformations, vertex, and axis of symmetry. Now, one thing come quiz or test time, you've got to be able to identify. You know, we saw the absolute value. Your brain was supposed to think v. Here, we see the squared. That's when my brain has to think, oh, that's that U shape, right? That's that parabola. Now, guesses as to what this parabola is doing? I wouldn't even call them guesses. You guys are going to know. What do you think? Okay, she says right 4. A minus 4 inside the parentheses is left or right, opposite the sign, correct? And up 3, because a number added or subtracted outside the parentheses is going to be up or down, direction of the sign. So that's up 3. So you can actually, if you want, go ahead and put that. Well, I'll throw it in words at the end. What does this mean about my vertex? My vertex is normally where?
0.
0, 0. What are we going to do with this vertex?
Move it right and go up 3.
Okay, we're going to go right 4, up 3. So I was at 0, 0. 1, 2, 3, 4. 1, 2, 3. Now, here's the difference part. In a absolute value, we just counted up 1 over 1, up 1 over 1. Can we do that now? No. So now, this is where it's really helpful to be familiar with this setup that we just did, right? From the vertex, the vertex was 0, 0 here, right? The first set of points go over 1, up 1, yes?
Yes.
And that's going to be over 1, up 1, both left and right. But what's the second set of points do? Instead of going over 2, up 2, it's going to be over 2, up 4. You need to work on kind of memorizing that, okay? Now, I'll tell you, Savas, if you have to graph on Savas, they don't require a bunch of points, do they? They just want the vertex and 1 extra point. But when I have you guys do this by hand, I want you to recognize that the next set of points is not just over 1, up 1. So, here's my vertex. So from the first set of points, I'm going to go over 1, up 1, over 1, up 1. Then I'm going to go back to the vertex, and this time, I'm going to go over 2, up 4. Over 2, up 4. And so that is from the vertex that it's the over 2, up 4. Not from the recent point, but from the vertex. If you're going from the recent point, it would just be over 1, up 3. But the 2, 4 is the number that makes sense with the equation. Yes.
How did you get the 2, 4?
Because this is an x squared equation, right?
Right.
So it's a parabola. And my basic form of the parabola is this 0, 0, 1, 1, 2, 4 that we did on that XY chart. So any basic parabola, as long as it doesn't have a stretch or a compression, is always going to have that 0, 0, 1, 1, 2, 4 setup.
Okay.
Now, we'll have to throw those numbers out the window when it comes to stretch and compression. But as long as this is just a 1x squared here, like there's nothing in front of there other than a 1, we can always just use that 0, 0, 1, 1, 2, 4.
So right now we're just finding the new vertex and then we're doing the back.
The original points, kind of, yes. Okay? And again, this is only because I haven't introduced any stretch or compression yet this morning, have I? Okay. I have not connected my dots. Did you try and make it look U-like?
Yes.
Okay? Again, if the dots are there, I'm probably going to go for it. Okay? But try. Okay, 3 pieces of information I'm asked to share. You got a vertex for me? Adriana? Yeah, we went right 4, up 3, so that makes my vertex 4, 3. What about an axis of symmetry then?
X equals 4.
Okay, I heard lots of 4s. Don't forget, x equals 4. Yep. Okay. And does this connection still exist that it's the first number of the vertex?
Yes.
Definitely. Okay. The other part was to identify the transformations, be able to put them in words. Yes, we already talked about right 4 up 3. What's the official algebraic word I'm going to be looking for? Good. We translate right 4 and up 3 units. Okay. Got the basics?
Yeah.
Could you answer domain and range on this if you had to? I feel like they maybe throw this in. They threw it in last night on you, didn't they?
Yeah.
Which I don't feel as bad about that one because we've talked extensively about domain and range last week, didn't we? So that wasn't brand new to you by any means. But domain, how far left and right does a parabola go?
Infinite.
Negative infinity to positive infinity every time, guys. Okay? How low does it go is for a range. How low does this go? In this case, it'd be a 3. Does it go through that 3 and touch that 3? Yeah, so that's 3 with a bracket, and then it goes up infinitely, right? Okay. Okay, next example. Y equals x minus 1 quantity squared minus 5. What do we see? What's something you see, Paul?
You translate right 1 unit.
Okay. It's a minus in the parentheses again, so that is left to right opposite the sign. So we're going to go right 1. Jayden?
Down 5.
It's a minus 5 at the end. So we're going to move down 5, direction of the sign. So what's my vertex do? Right 1. Down 5. Okay. Now what?
You do
Up,
up
over
1 over 1 and then
Up, down,
Down,
over
right
2, up 4.
Okay. So the first set of points on a, now, and why are we doing this? Because it's a quadratic, right? It's an x squared equation. I see that x squared. That's why I'm doing this. So first set of points, over 1, up 1 in both directions. Second set of points,
Over 2, up 4.
over 2 and up 4 in both directions. And as I've said several times today, attempt to make it a U shape. I'll be the first to agree, easier said than done sometimes.
Solves will be made easy.
Savas will make it very easy. Okay, what's my vertex on this one?
1, negative 5.
Okay, we went right 1, down 5 for 1, negative 5. What's that axis of symmetry?
X.
Okay. X equals always the first number of the vertex, so x equals 1. And our transformations, we,
Translate right 1 unit
Down 5 units.
okay. Translate is our word for move or shift or, so translate right 1 and down 5 units. I think some of you guys had that one done before I ever even started graphing, didn't you?
We might just get this all done today.
That's the plan. Now, and why is some of this moving so much quicker?
Because we did the easy stuff first.
Yeah, we've already done this with absolute value, yes? And so, whichever I introduced first was going to be the harder stuff. Okay? That's what it comes down to, because it was all new. Now, we're building on what we already know. Okay? And so, yeah, I'm tweaking some things, like instead of doing the V, we have to do the U, but it's all there. Okay. But if there's a hard part of the lesson, it's the next part. That's what I'm going to go with. We're graphing again. Identifying the transformation. Doesn't say anything about vertex and axis of symmetry, but what do you notice here? What do you see? Patrick?
There's fractions.
There's fractions. Our friends, right?
Yeah.
Yeah. Paul?
Vertex compression.
Vertical?
Vertical.
I'm guessing is what you mean? You had the start of the word. Okay.
Vertical compression.
Why is it a vertical compression?
Because it's not more than 1 and it's not less than 0.
Okay, so 1/3 is a value between 0 and 1, and we're multiplying by it out front, so that makes it a vertical compression. Is this graph going to move left, right, up, or down? No, which means where's my vertex going to be? My vertex is going to be at 0, 0, which is probably why I didn't ask for vertex and axis of symmetry here, because if we're not moving, we've got the basics. Now, here's the catch. You don't get to do just over 1, up 1, and over 2, up 4 now. We also don't get to rise 1, run 3. Okay, this is no longer a slope. We can't think of it as slope because this does not involve straight lines. This involves the U shape, right? The V, it involved 2 straight lines in a way, didn't it? So that's why I could think slope. We've got a U shape. We can't think slope here. Now, my best suggestion at this point in our lives is that we think about an XY chart to get that extra value that we need. And so when we think about an XY chart, we already know we're going to use 0, yes?
Mhm.
And without even plugging in, we've already talked about the vertex is going to be 0, 0. Now, mathematically, does that make sense? 0 squared is 0. 1/3 times 0 is 0. So that all should make sense. Now, earlier, I used 0, and what else did I use?
Oh, one.
1 and 2, and then I use the negatives. Now, with a parabola, if it's centered at 0, 0, I'm always for just use a couple of positives, and then we can reflect to get the negatives. Now, do we really want to use 1?
No.
Why not?
That is too close.
If I put in 1 here, 1 squared is 1, and 1 times a third is
1/3.
1/3. Can you graph the point 1, 1/3? Not easily, right? Not accurately. So, what's a good number to put here as my x value? Why 3?
3 times 1/3.
Yeah. Well, except we're not going to do exactly 3 times 1/3, but with a denominator of 3, life will be better here. Okay, with the denominator of 3 and using 3, that's a good one. Now, if I want to use one more number, you don't have to do this in Solvus, but I want to practice this. Why 6?
It's a multiple of 3.
Good. Okay, so here's my general rule. When I see a fraction, I'm going to look at that denominator. I have a denominator of 3. Multiples of 3 are going to be your friend in this problem. Okay, so let's do a little bit of math. If I put 3 in, we got to do the math properly here. That's going to be 1/3 times 3 squared. What do we have to do first in that?
Yeah.
You have to square the 3. I always say I have to think about my Aunt Sally. You guys know Aunt Sally?
I've heard of it.
Yeah.
You guys don't talk about Aunt Sally. You guys talk about what? PIMDAS?
Yeah.
Okay. I always say Aunt Sally. I'm old school. I always say, please excuse my dear Aunt Sally. Okay. You guys, PIMDAS, right? So the idea is that exponents come before multiplying is where I'm trying to get you. So what is 3 squared?
No, 9.
9. And so then I'm doing 1/3 times 9. What is a third of 9? 3, right? Take 9 and divide it by 3. Okay. While we're here, we're going to go ahead and put 6 in. So it's 1/3 times 6 squared. Exponents before you multiply. 6 squared is,
36.
oh fun, 1/3 times 36.
12.
36 divided by 3, right? So that is 12. Okay, a little bit bigger than what we really want to graph, but gives us the idea. So we already have 0, 0 here. Our next set of points,
3, 3.
3, 3. So that means I'm going to go over 3, up 3. If I do that on the right, I also do that on the left. My next set of points, 6, 12. So I'm going to go over 6, and I'm going to go up 12. Now, my graphs go up 10. I am not opposed to if you need to go off the graph a little bit, make it a spacing appropriate. That's perfectly fine. I'm also going to go left 6 and up 12. And again, do your best to make that U shape. Okay? If you didn't already write it down, I probably should have done this earlier when we talked about it, but write down your transformation, which in this case was a vertical compression by a factor of 1/3. Okay. Next example when you're ready. What are your thoughts about y equals -3/4 x squared? What are you thinking, Ruby? Not quite. Partially there. Patrick?
The parabola is going to be upside down.
Okay. Why is my parabola going to be upside down?
There's a negative.
Okay. This negative out here, right? This negative tells me we're going to reflect.
Across the X.
And that was going to be my question. Where are we reflecting across?
The x-axis.
The x-axis. So I'm going to go ahead and come down here and write this while I'm thinking about this time. That we're going to reflect across the x-axis. And what else are we doing besides reflecting across the x-axis?
Vertical compression.
Vertical compression by a factor of,
-3.
not -3/4, but just 3/4, because that negative was my reflection indicator. Okay? So this is a vertical compression by a factor of 3/4. Realize I have 2 vertical compression options in here. I picked to do both vertical compression examples because that forces us to use fractions. And where are you guys going to be more likely to struggle? With fractions. If this had been a whole number or a number bigger than 1, could we still have a vertical stretch?
Yes.
Yeah. Okay. Though you will still see those, but I felt like fractions were my better option here. Okay. So the key again, we could go ahead and talk about where's our vertex.
0, 0.
0, 0, because no left, right, no up, down. So it's going to be 0, 0. I'm going to encourage you, anytime there's a stretch or a compression, I'm going to encourage you to think XY chart. Okay? Zero is always my friend. But we already know 0 is going to be 0, 0. What other numbers you want to try here? Logan? Would 2 work?
Probably.
Okay. I heard 4 also. Why are we saying 4? It's a denominator, yes. Okay. And here's where we have multiple options. Okay. Why would 2 work? Because when you square 2, what are we going to get? 4, yes? Okay. So in the case of 4, yes, 2 works. Okay, I like it. 4 works, yes? If you pick 4 as your first number, what's your next number you could pick if you didn't think about 2? We'd have to go up to, actually would. I was going to say 6 wouldn't work. It's not a multiple of 4, but it would happen to work. Okay, but the next multiple of 4 would be 8, yes? And here's what general rule of thumb is multiples of 4. So those of you saying 4 and 8, yes, 4 and 8 work. Okay, that doesn't mean those are the only options that work. 2 is always a great option when you have a denominator of 4. It just so happens, I was just thinking about 6 would work. It would be nice. Okay. I personally, if I think about it though, I'm going to pick 2 and 4 on this one. Okay. If you pick 8, that works too. Okay, so what are we going to do with this 2? We're going to plug it in. So it's going to be negative 3/4 times 2 squared. We're going to do those exponents first. 2 squared is 4. So I have negative 3/4 times 4. 4 as a fraction is 4 over 1. What about those 4s? They cancel, and I have negative 3. So 2 works, doesn't it? It gives me a whole number. Okay? Negative 3/4 times 4 squared. Well, that's going to be negative 3/4 times 16. I think cross cancel. 4 divided by 4 is 1. 16 divided by 4 is 4. And so then I'm doing negative 3 times 4, which is negative 12. I seem to be liking the 12s today. Okay. Does it make sense my y values came up negative? Yes, because we're supposed to be upside down here, yes? So from my 0, 0, I'm going to go right 2, down 3. I can also go left 2, down 3, because I can reflect this. We can also go right 4, down 12. And we can go left 4, down 12. Okay. I thought about something midway through this problem. We've been graphing the parabolas, yes? I'm pretty sure there's at least 1 or 2 in homework that also ask you to graph the axis of symmetry. When they ask you to graph the axis of symmetry, they ask you to use a dotted line. Well, where would the axis of symmetry go? It's going to go down the middle, yes? So you could graph a straight line down the middle right there, yes? You'd be more likely to see that on the other page. Hello? Oops, can you grab it? Okay. So just an FYI, watch your directions. Do you have to do a axis of symmetry in all of them in homework? No, but there's some you do. So if it asks for it, it's going to count you wrong if you don't do it, and it will tell you to use a dotted line. Okay? Thank you. So, and if I backtrack for a moment, that means like if I go to the back of the front or the bottom of the front page, an axis of symmetry here would have been right through there, yes? You could do that if you had to.
So that would be the x1.
X equals 1, right? And honestly, these are the ones that are more likely to have you do an axis of symmetry. The ones that stay centered at 0, 0, they're probably not going to ask you to do an axis of symmetry. It's going to be these. Okay? Okay. One last topic. At the bottom here, vertex form of a quadratic equation. We had standard form and general form of an absolute value yesterday, right? And it used that A, that H, and the K. Well, now we have the same thing, except again, we're thinking quadratics, aren't we? So notice there is an x squared. A is still the stretch or compression factor. The vertex is still at HK, and your axis of symmetry is x equals h. The idea here is to be able to take a random graph they give you and write the equation. Okay, so we're just reversing what we've been doing. So we're going to look at this first example here. And what we're trying to do is we're trying to write the equation in the form y equals a times x minus h squared plus k. So basically you have to be able to pick out your a, your h, and your k. Can you do it?
I don't know, we'll find out.
2 of those 3 shouldn't be bad. What can you easily pick out of A, H, and K? Ruby?
K and H.
The K and H, because they are my vertex, yes? What's my vertex? -1, -4 is my vertex, yes? And so that makes those values my H and my K. Okay? So right there, I already know my H and K. I know I'm going to be doing y equals, I'm going to leave the A blank for a moment, x minus, my H value is -1 squared plus K. Well, it's plus -4, but what's the better way to write that? You're not going to see me normally write plus -4. I'm going to write -4, yes? Just like, am I really going to leave this as x minus -1? No, I'm going to change it to x plus 1. Now, what about our A value? So the question for A, is there a vertical stretch or compression?
No.
Why not?
There's points at 1, 1, 2. Like 1, 1.
Okay. If you look from your vertex, can you go over 1 and up 1 and get to the first set of points? Yeah. Can you go over 2, up 4, and get to another set of points?
Yeah.
Okay, that's our basic parabola shape, yes?
Yes.
That's the parabola shape we've been talking about all period. And so right there, because of that, I know my A value is just going to be 1. Or in other words, am I even going to see A in my equation? Normally we don't even put anything there, right, if it's 1. So if I'm writing this out for final answer, I'm going to have y equals, parentheses, x plus 1 squared minus 4. In all honesty, I'm not going to count you wrong if you put in a 1 in that A spot. I could see Savas being that way though. Okay. So don't put the unnecessary ones because Savas does get kind of nitpicky about that. Okay. One more. Again, we're trying to fill in that form. Y equals A times x minus h squared plus k. What do you see?
Your vertex is 2, 5. Well, -2.
-2, 5?
So that gives you your
So right there we know our h and k, yes? Now, the trick becomes, what about A? Does that work here?
Probably.
Well, because what that is that's for slope.
Yeah, but it doesn't.
But we can't think slope here. Now, what I'm trying to figure out is does it just happen to work? And I don't think it's going to just happen to work either.
Is that a vertical
Okay, well, and so here's what you need to be able to identify. Okay, we have this point, yes?
Yeah.
Guess it kind of works for the first one. Okay, where is my first point in relation to that vertex? We can go over 1, and how far do we have to count to get to that first point? We have to count down 3, don't we? So we need something, and then when I put that first point in, it's going to get me to that down 3. Slope doesn't exactly work when you get past the first set of points. But it does kind of work if we're just going 1 over. Does that make sense? I wish I could remember exactly what homework does. So how we went the over 1 down 3, except we're not going to say, I guess you want to say down and then over, don't you? Okay, because we talked up or down and then over. So if you're just going 1 from the origin, you can use an A value here of 3. Okay, it does work. And I'm trying to think if you have any that you can't just count 1 over. I'm not sure off the top of my head. So what's the other key about A? Did anyone say it? I mean, technically A is going to be 3. But what else do I have to throw in there? What's my parabola doing?
Going down.
So it's going to be a negative. Okay, so when we write this, it's going to be negative 3 times x minus negative 2 squared plus 5. Except what I'm going to write for final answer, negative 3 times x plus 2 squared plus 5.
What do you do when it's not 1 over?
That's what I'm trying to think if we have that at this point in our lives. Okay. It's going to come down to maybe having to plug some values in to try it. I'll have to double check. I feel like we're just going for 1 over, the ones that are 1 over at this point. But let me double check and I'll let you guys know. Okay. Your homework. It's going to show as lesson 1.2, but what's it say this time? Quadratics. And this is found in Savas. Okay? And this will be due tomorrow. Okay?
15-ish.
If